Welcome to the Application Performance webinar on what SharePoint can learn from e-commerce. I'm Zoe Buckingham, AP's Head of Marketing, and I'd like to introduce Mick McGuinness, one of our directors and a foremost expert on SharePoint performance issues. Please type any questions you have in the questions box in your control panel, and Mick will be pleased to answer them at the end of his presentation. Thank you for joining us, and over to Mick.
Thanks, Zoe. Good afternoon, everybody. So my name is Mick McGuinness. I'm the co-founder and technical director of Application Performance. We're a UK company that specialises in monitoring and accelerating applications, and we've been doing that successfully now for over 10 years. In particular, we work with many SharePoint and Office 365 customers, ranging from very small right the way through to some of the very largest organisations in the world who have SharePoint users in every country around the globe. We also work very close with some of the well-known e-commerce retailers, helping them to optimize the performance of their websites as well. And what we find in general, but not always, is that e-commerce customers seem to understand the importance of performance and the effect that it has on their revenues. Usually they've got good monitoring in place where they can see the experience that they're delivering to their end users. And in some cases, they'll even have dedicated performance teams whose job it is just to be purely responsible for the performance of the website. SharePoint, on the other hand, typically doesn't have any of that. Usually there'll be a number of SharePoint architects, developers, administrators, and maybe outside consultants who develop and deploy and maintain SharePoint, but usually nobody who is dedicated as a performance specialist. Also, the monitoring tools are often lacking, with SharePoint teams relying on other infrastructure teams to monitor the servers, the network, and the SQL databases. But what they miss is the view of the end-user experience. So often they rely on an end-user complaining as a way to know that things are going slow. But with these kind of anecdotal reports, there's no way to know whether it was slow just for that one person, or whether it was slow for everyone, or maybe just a subset of users, like those accessing a particular site or a particular page, or those users in a particular location. So the presentation today aims to redress the balance and to get some of that knowledge which e-commerce sites rely on into your hands so that you know what you can and what you should be doing to improve the performance of SharePoint. So broadly, these are the topics that we're going to talk about. We're going to have a look at e-commerce performance first of all, and I've got some really great examples there. We're going to talk about why it matters and then the tools and techniques that they use to optimize performance. And then we're going to go and have a look at SharePoint. Again, go through the same thing, why it matters, and then the tools and techniques that you can use. And without spoiling the presentation too much, obviously there's a lot of commonality between these two. They're both web-based applications delivered to end users through a browser, so a lot of the same tools and techniques apply to both. At the end of the session, which is about 30 minutes, we'll have some time for questions, and then anybody that wants to stay on after the questions for an extra 10 minutes, I will show you a demonstration of some of the monitoring tools. So first of all, we're going to talk about e-commerce and the question of why performance matters. So at the end of the day, it comes down to this stuff. If your site isn't performing, then you're losing money. And the reason for that in the e-commerce environment is down to either increased cost of running the site, and that could be down to more support calls that you're having to field, more time for your IT staff to do troubleshooting, or maybe more hardware if you're trying to solve the problem by throwing hardware at it. On the other side, your site could be losing revenues. So anybody that's shopped on an e-commerce website, which is probably most people, will know you're going to get that immediate lost revenue because that user, if they're getting really slow performance, will abandon the site and will go and buy the same thing from one of their competitors. If the site is slow enough for a long time, then there's potential damage to the brand as well. And then there's a loss of potential revenues. So once somebody has decided to go away from that site and shop elsewhere, then the chances are they're probably not going to go back to that site again in the future, and they may tell their friends and family and colleagues about that poor experience. And then finally, something that applies in the e-commerce space is search engine ranking. So Google now, for over 2 years, have been factoring in performance in their search rank algorithms. So slower websites will get penalized and you won't appear in the top 10 listings. So I've got some examples that I want to share with you. The first one here comes from an independent research group called the Aberdeen Group. This is going back a few years ago now. They did this study, and this was across a number of e-commerce sites. The figures you see here are kind of average results across that. And what they concluded was that a 1-second delay in page load time had this impact on the success of that site. So 7% drop-off in conversions, that's the number of people that are buying from the site. 11% decrease in page views, so people are viewing less pages if the site is slower. And then a 16% decrease in customer satisfaction. And that's just from a 1-second delay. So obviously if the site is delayed by 2 or 3 or 4 seconds, then these figures start to increase further. And what that means to a kind of small to medium e-commerce business, somebody that's turning over maybe $100,000 a day, that's affecting them to the order of $2.5 million a year in sales from just 1-second delay. So obviously performance is important for all these things. I've got a few more examples here. This one comes from Walmart, a shopping chain in the US, and what they found was they could see this very sharp decline as performance got worse. So what you see across the bottom axis here is the page load time, increasing out to 15 seconds. And what you see here is that the conversion rate, so that's the number of people that are actually purchasing from the site, is high for those users that are getting 1-second page load times, drops off sharply for users that are getting 2-second average load time, drops off again 3 seconds, 4 seconds, and then after that starts to plateau. So they know that if they want to maximize the number of people buying from their site, they want the most number of users to be up here getting that 1-second page load time. Here's another metric that's important in the e-commerce space. This is bounce rate. A bounce is when somebody hits the website and then immediately leaves without viewing any subsequent pages. And again, you can see from these figures, this is across a number of e-commerce sites, so it's kind of aggregated data, where you can see here that as load time increases on this axis, the bounce rate starts to increase as well. So if you're having a very slow page, then people are leaving the site before they've even visited the first page. Here's an example from a UK company, Seatwave, who we know very well. They presented this at one of the conferences last year. What they did was they segmented their users into 2 groups. The users that were getting less than 4 seconds as a page load time, and the users that were getting greater than 4 seconds as a page load time. And then what they found from their monitoring was this. Basically, the users that were getting the better performance, they visited twice as many pages on average as the group that were getting slower performance. Those with the good performance were 6 times less likely to bounce off the website. And conversion rate, which is ultimately the most important thing for an e-commerce site, was almost 30% better for the users that had the better performance. So again, obviously, very, very strong correlation there. So that leads to the question, what is good performance? You've seen a few examples there. Is it 1 second, 2 seconds, 4 seconds? And really, there is no kind of hard and fast rule for this. I've got a few more examples here where some studies have been done to have a look at what users are expecting. So this one here comes from a research group called Focusrite. This one focused particularly on online travel sites. In this case, what they found was 57% of consumers abandon a website after waiting just 3 seconds. So 3 seconds doesn't sound like a lot, but in this case, you've already lost half of your potential customers. Another example here from a company called Akamai. This one was based on a survey, so that they asked potential customers what they expect a web page to load in. And the answer that they found was 2 seconds in most cases. So 47%, so almost half of users expect less than 2 second page load times. So going back to the question, what's good performance? It really depends on what the end user is expecting. If the end user, for example, was expecting a page load time of 2 seconds, like you see here, and they got a page load time of 4 seconds, the user would perceive that as being bad. Whereas, if a user had expectations of a page load time of 8 seconds and they got 4, then they would probably perceive that as being good. So it really depends on the end users. And when you start to look at SharePoint deployments that spread around the globe, you'll see that not everybody has the same expectations. Users in the UK, for example, may be expecting 2 seconds or less, whereas somebody in Africa may be happy with a lot more than that. Once you get to the very high throughput websites, if you're operating at the scale of Amazon or Yahoo, then even milliseconds make a difference. They have so many hits per day, they can actually detect that 100 milliseconds improvement in the case of Amazon would give them a 1% increase in revenues. With Yahoo, 400 milliseconds improvement gave them a 9% increase in traffic. So I don't think there's many SharePoint farms that are kind of operating at this kind of scale, but it just kind of shows you that performance is critically important. Even small delays can make a big difference. And then finally, before I move on to talking about SharePoint, last example here from e-commerce. This one takes a slightly different way of looking at things. So rather than just looking at the metrics like bounce rates or conversion rates and how those relate to performance, this one actually looks at it from the human side of things, looking at brainwave activity to see the stress levels that are actually induced in end users when they're trying to interact with a site that runs slow. So in this study, the way the study was done, the users wore these EEG brain scanners that measure brainwave activity. Half of the study group connected to their normal e-commerce sites. There was 4 of the most popular sites were chosen for this experiment. Half of them connected directly, just using their normal smartphones. The other half connected through a wireless hotspot, which had a half-second delay introduced. And what they found by measuring the brainwave activity was that there was a 26% increase in peak frustration levels for those users with that half-second of delay. So if you're delivering slow performance, you're causing frustration for your end users and stress, and that's the reason why they're less likely to purchase. So what's all that got to do with SharePoint performance, and what can SharePoint learn from that? Well, first of all, why performance matters in the SharePoint space. It's exactly the same reason. At the end of the day, it's going to come down to money. If you're not performing, then either you're costing more to run your SharePoint farm, so you're having to do more troubleshooting, more support calls, potentially more hardware, or it's decreasing your revenues, which is kind of slightly different to in the e-commerce example, but it's maybe a little less clear-cut in being able to relate performance to some of these other metrics. But what you can say is that if you're delivering SharePoint and it's slow, those users will be less productive. They will use the system less. In worst case, they will not use it at all. They will revert back to old ways of doing things, saving documents locally or on local shared drives rather than put it into SharePoint. And if that's bad enough across the board for a large enough group of users, then that can ultimately lead to a failed project. So that's the worst case scenario. You may have invested tens of thousands or hundreds of thousands or even millions in your SharePoint deployment, and if performance is bad, then people will just refuse to use that system. And it's very difficult, having gone live and had issues like that, it's often very difficult then to kind of relaunch and have a second chance at making a first impression. So the important thing to remember here, those users that we were just talking about a couple of minutes ago that are expecting 2-second page load times or less from their online shopping experiences, those are the very same people that are coming into the office and using SharePoint. So the chances are that their expectations around performance will be exactly the same. So the next question then is what affects performance, whether it's e-commerce or SharePoint, what affects the performance of a website? Well, you've got, in simplistic terms, three components here. You've got the client side, you've got the network connection, and then you've got the server side. On the client side, the two most important factors are the hardware and the software. If you've got a newer PC, lots of CPU, lots of memory, latest version of Internet Explorer, version 11, then that is likely to load a page a lot faster than something that's 10 years old, running Windows XP and IE7. So on the client side, there's often things you can do there to upgrade your end users, and that can make significant difference to the performance. Number two here, that network connection, this is even more important than the hardware and software of the end user client. It's the conditions of that network connection between the end user and the server. That could be a WAN connection, it could be a LAN connection, it could be the internet in the case of Office 365. There's a number of things that you need to look at on the network, but the two most important things are the latency and the bandwidth. Latency is the round trip time. How long does it take packets to go to the server and back again? Bandwidth is how much data you can get per second. And we'll have a look in a bit more detail at those two in a second. And then finally, on the back-end server, you've got your SharePoint farm, you've got the speed and scalability of those back-end servers, your SQL database, and any custom code that happens to be running there. And so we'll have a look at that as well. So just to introduce some terminology, in the web performance world, we often talk about front-end and back-end. So the back-end time is how much time out of that page load time, how much of that time was spent on the back-end servers, which is basically executing .NET code, doing any SQL queries that need to be done, and generating an HTML document. That's the back-end time. Once you've got the HTML document, you then have to then ship the HTML back to the browser, and then the browser can start to fetch all the objects that are referenced within that, all the JavaScript, CSS, and images. And that's the front-end time. So in order to look at where the time is spent on loading the page, you need to start off by working out, have I got a front-end problem or have I got a back-end problem? So the way you do that is to have a look at what's called a waterfall diagram. And a waterfall diagram looks something like this, and you can get these from any of the browsers. Internet Explorer Developer Tools will give you this. Same thing in Firefox, in Chrome, or there's other plugins like HTTP Watch or external services like Web Page Test. Lots of ways you can get these. What this is showing you is how long it takes to load everything on the page. So the list here is, at the top of the list you've got your ASPX, which is executing some code to generate the HTML, and then everything else then is the static content, your CSS, JavaScript, images like GIFs, PNGs, JPEGs, and so on. So if I was to highlight front-end and back-end over that picture, the shaded area that you see there, that is the front-end time. And in this case, it's about 95% of the page load time. So from about 0.4 of a second through to about 9 seconds, that's the front-end time. It's loading all the content on the page. The back-end time is actually the green bar that you see there at step 1. And it in this case amounts to about 0.3 of a second. That's how much time IIS spent basically building the HTML for this page, and that includes any SQL queries or anything else that needed to happen. So if you're going to tune that page, if you would start by looking at the back-end time, you would probably have no difference whatsoever. Even if you reduce that 0.3 of a second down to 0.2, the end user is not going to notice that. If you want to speed up that page, the only way to do it is to look at the contents and how you can get those contents back to the end user faster. So one of the biggest things that affects that front-end time is the network conditions, as I said earlier. So first of all, the most important thing is distance between your end users and your SharePoint farm. If we look at this example here, we've got a SharePoint farm that's hosted in London, and it's serving users out of New York and San Francisco. And what you find is, if you load exactly the same page from those two locations, you might find something like this. The user in New York, he's getting 6 seconds. the user in San Francisco is getting 11 for exactly the same page. And the only difference there is network latency. This may be 100 milliseconds round trip time. This may be 200 or 250 milliseconds round trip time. And that makes that much difference overall to the page load time, just because of the nature of what you saw in the waterfall diagram, the number of round trips to load the page. So given that kind of scenario, you may think, well, can I speed this up by just adding bandwidth? Because bandwidth is easy. You can upgrade a connection, 10 megabits, 20 megabits. But what you find is, no, that actually doesn't make any difference whatsoever. This is a study that Google published last year. This is looking at page load time, PLT, as bandwidth increases. So as you go from 1 megabits to 2 megabits to 3 to 4 to 5, and you see very rapidly it tails off. So in fact, if you went from 5 megabits to 10 megabits, so you're doubling the bandwidth, the difference to the page load time would be somewhere of the order of 5%. So throwing bandwidth at the problem is not going to solve the issue here. The problem is RTT, round trip time, which is latency basically. So if you look at this chart here, you can see if you've got 0 latency, so you're loading the web page on the server itself, then the page may take half a second to load. By the time you get up to 240 milliseconds latency, which may be, for example, UK to West Coast US or UK to Hong Kong or Singapore or China, then that exact same page is going to take 4 seconds to load, just purely down to latency. So how can you speed things up then in that case? You can't throw bandwidth at it, and you can't reduce latency, because latency is just a factor of the physical distance. Those packets are traveling close to the speed of light, and we're not going to break the light speed barrier to get the packets there any quicker. So what can you do? So basically what you need to do is look at the page composition, look at the number of resources you've got on the page, and then the size of those. So a typical web page is made up of an HTML document, and then a number of CSS files, a number of JavaScript files, and a number of images. That's the building blocks of a web page. So what you need to do is to reduce all of these. So with CSS files, combine them into a single CSS file. There's no reason to have more than one. Condense that into one single CSS file, and that will reduce all those round trips. Same thing with JavaScript. Sometimes it's not always the case where you can condense everything into a single file, but certainly reduce the number of JavaScript files by combining things together. And then with images, it gets a little bit more tricky, but there are techniques you can do, some kind of advanced techniques like image spriting or embedding images, base64 encoded, into your style sheets, which can actually reduce the number of image requests as well. And then you need to look at the size of all those objects. So with CSS, JavaScript, HTML, these are all text-based resources. You should be doing, as a minimum, gzip compression on all of those. But there are also other things like minification, so stripping out comments and unnecessary code, which you can also do to shrink the size of those as much as possible. When you come to images, again, it's a little bit more complex, but there are ways you can optimize images for the web, stripping out metadata, resampling images so they look the same but take fewer bytes to download. And so, yeah, I saw an example a couple of weeks ago. Somebody had a web page. They had an image that was 300 by 200 pixels, but the actual image was 10 megabytes. It was something that had been taken on a digital camera, and it was downloading the entire image and then scaling it within the browser. So obviously that's an extreme example, but that's the kind of thing to avoid. And so you can do all of this manually, but there are automated tools which we work with and we can recommend that can automate that whole process for you. If you wanted to do this manually, then I'd recommend that you look at some of these tools. YSlow is a tool from Yahoo, available as a plugin for Chrome or Firefox. This will grade your website against the rules that you see here, and it will give you an overall score. And then it will highlight which of these you're not optimized on, and some recommendations about what you need to do there to optimize. There's also another one from Google called Google PageSpeed. It's pretty much exactly the same. The rules are slightly different, but it's mainly the same kind of rules. And again, this will grade your website and tell you where you need to improve. Again, that's the Firefox or Chrome plugin. So that's front-end optimization, and as I said at the start, that's typically where most of the time will be spent. When you look at a web page, it will be somewhere between 80% up to 95% of the time will be front-end time. But what about the time when it's not a front-end problem? What about when it's a back-end problem? What can you do there? So in that kind of scenario, I would always start with a waterfall chart again, and this would prove, first of all, is it definitely a back-end problem? The way that would show up is that step number one would be a very long green bar showing you've got a very slow time to first byte. So the browser is waiting for the server to respond with the first bit of HTML. So that's telling you've got a slow back-end time. Within SharePoint, you're actually quite lucky because you can then click into that, and there are some additional headers which Microsoft provide, which can give you a little bit more detail. So you've got the ones that are highlighted here, IIS latency. That's the number of milliseconds that the request was queued before it was processed. So you want to see that 0 if possible, or certainly close to 0. If that's high, then it means that you've got a throughput issue within IIS. You've then got the whole request duration in milliseconds, so 491 milliseconds in this example. That's how long it took SharePoint to generate the whole request there. So if that's a large number, then you need to start looking at the back-end time. And then finally, you've got the SharePoint health score, which is a score from 0 to 10, which will tell you at the point in time where this page was requested, how healthy was the SharePoint farm. And if that score is high, approaching 10, then that means that SharePoint was very unhealthy at that point in time, and therefore it's not something specific to this page. It's a wider SharePoint issue, and it may be that the servers were short on RAM. It may be that they're short on CPU. Maybe that they had too many requests coming in, and IIS was under stress. So lots of things you can look at there to kind of pinpoint where the issue is. Having identified that you've got an issue within a particular page, there's a couple of ways you could go about then fixing that. One would be to use the SharePoint Developer Dashboard, and that would tell you where the time was spent. So you can see here in milliseconds on each of the requests and each of the SQL database queries, how much time was spent there. Or what you could do is, by a process of elimination, strip the page back to a blank page and then start to add things back in one at a time until you identify which web part or which thing was causing the page to run slowly. If a blank page still runs slow, then have a look in the master page, because it must be something then that's included in the master page. The typical things to look out for: too many web parts or slow web parts that might have been misconfigured, slow SQL, deep navigation, content rollup. So monitoring tools that you can have a look at. First of all, some free ones. These are troubleshooting tools. You probably know a lot of these already, but if you've got a problem, have a look at the developer tools in the browsers. Have a look at YSlow and PageSpeed that I mentioned. Looking on the network side, just ping, traceroute, that'll tell you round trip times. On the server side, you probably know Perfmon, Task Manager, Process Explorer is quite a nice one, Parts List Internals, and the Developer Dashboard. So those are all good tools for kind of troubleshooting problems that you might have right now. But we also recommend that you should have some ongoing monitoring as well. So on the server side, you need to be monitoring the servers and the SQL databases, and also IIS. You need to be looking at the network health continually to see how much bandwidth you've got, how much that's utilized, and what the round trip times look like. And then on the end user side, two ways of monitoring end user experience. One is real user monitoring, and that's the way, if you remember back to all my e-commerce examples at the start, that's what the e-commerce sites are doing to understand for their real end users what level of experience they're delivering to them. So that's real user monitoring. But you can also do synthetic monitoring as well, which is basically where you hit the site every 5 minutes, just check some of your key pages and just test the availability and what the the response time is like from a known test location. So those are what we recommend. Now, as a company, application performance, we can provide all of that. We do monitoring end-to-end, all the way from end-user experience all the way through network and server. And we can also do acceleration as well. So some of the acceleration techniques that I talked about, which will speed up page load times, also speeding up file transfer, so document uploads and downloads. We've got solutions for all of that. So if you're interested in any of that, then get in touch with us. So I think that was my final slide. I did have a demo, as I said, so if people want to stay on after questions and hang around for another 10 minutes, I will demonstrate some of the tools. But I guess now I'll hand back to Zoe, and we can run through any questions that might have come in.
Thanks, Mick, for such a useful overview of the issues faced by e-commerce specialists. It's interesting how many of them can be transferred into the SharePoint space. While Mick was speaking, a number of you asked questions which I'd now like to pose on behalf of the audience. Mick, is all of this relevant to Office 365 as well, or just for SharePoint on-premise?
So yes, most of what I talked about is applicable to both Office 365 and SharePoint on-premise. The difference, obviously, is with Office 365, you can't monitor the servers. Those are hosted for you and provided by Microsoft, so you don't need to do any server monitoring. You don't need to do any database monitoring. But everything else is definitely relevant. So monitoring network links from your end users to the SharePoint online, and also monitoring end user experience for all your users to see what level of experience they're getting is all relevant as well. So, so yeah, definitely applicable to both. And we have customers that work with both SharePoint on-premise and Office 365.
Thank you. And it is interesting, as Office 365 grows in terms of the number of people using it as well, it's obviously going to become more important. And also, you mentioned real user monitoring. What's needed to set that up?
So with real user monitoring, it's actually really simple to set up. You can just put a small piece of JavaScript into the pages that you want to monitor. And in the SharePoint or Office 365 environment, typically you would add that into the master page. There are other ways. If you're on premises, there are other ways you can do it. You can do it through the Microsoft URL rewrite plugin as well, or through your load balancer. But once you've got that JavaScript into the page, which is just a very small snippet, you can just copy and paste from the website. What that will do is it will then time page load times from the end user perspective, and then after the page load is actually completed, there's one additional request, which is then to beacon back the metric data to a central server. And that central server can be provided by us, and customers use that as software as a service, or it can be a server that you host yourself. And then basically the data that gets stored there is a record of every single page view from every single user and what the page load time was. So you can then start to aggregate all that up and look for trends over time, look for trends across different users, different locations, different browser types, and just to see how performance varies across those. That will then point you to where you need to spend time optimizing. Because as I said, I think in my introduction, it may be that it's not every user across the entire site. It may be subsets of users or subsets of pages that you need to focus on. And real user monitoring kind of points you in that direction.
Fantastic. Thank you. Thanks for your answers, Nick, and thank you to everyone for listening and contributing such interesting questions. This webinar is being recorded, and we'll send you a link to the recording in the next few days. If you'd like to see a demonstration of the WebTuner monitoring software that Nick mentioned, please remain on the webinar. Otherwise, thank you for attending, and we look forward to speaking with you again soon. Goodbye.
Okay, so for those that are staying with us, I'm just going to bring up our WebTuner real user monitoring solution. So So I think in one of the questions I already just explained how this works, which was it's a small piece of JavaScript that you can put into your master page or somehow get into the pages that you want to monitor. And then it's going to send that data back to a central server where you can then start to drill into the data. So the portal, this is probably timed out, so I probably just need to log back in again. And this is kind of aggregated data across a lot of different SharePoint sites. So what you can see is so here you've got users that are coming from all over the globe. The bubbles on this map here indicate where the users are coming from. The size of the bubble is the number of pages that were requested from that location, and the color is basically the performance. So you've got red, amber, green, depending on what the performance was like. So in this case, most of the page requests are coming from the UK, and load time for users in the UK was 4.6 seconds on average. If you look at Scandinavia and parts of Europe, performance is green. As you start to get further away, performance can degrade. So somebody in Turkey there, 28-second load time. Somebody in China there, 15 seconds. Japan, 9 seconds. Taiwan, 14 seconds, and so on. So plenty of examples there of quite poor performance. And this is a good way of illustrating whether it's that network latency that I mentioned that's causing the issue. If you see that users, as they get further away from your SharePoint farm, start to get worse performance, then one of the most likely reasons is it's down to network latency. So, for example, let's pick a country to zoom into. Let's look at China. So China has an average of 15-second page load time. You can see we've got users in various different locations here. Let's have a look at this one. So here's a user. They were getting 7.5 seconds, and they did 10 page views. So let's have a look at them. So we can go down now into an individual user session, so going all the way from a kind of high-level map of the world down to an individual user. So we can see their IP address, their country, the browser they were using was Internet Explorer 8, the operating system was Windows 7. We can see how long they spent active within the site, and then we've got the full click stream for all the pages they visited. So it was one page here in particular that had a very slow page load time, 23 seconds. And what we've got here is we break that down into the blue and the green. So the green is that time to first byte, which indicates a back-end problem. And the blue is then everything else then to load the page, which is loading all the images, style sheets, and JavaScript. So you can see whether it's a front-end or back-end issue. This is kind of nice for if you've got a particular user that's complaining that you want to be able to troubleshoot, and you can go all the way down to have a look at their session and see what they were doing. If you were trying to be more proactive in fixing performance, though, you would probably go to the Performance tab, have a look at a period of time. So I'm just going to select 12 hours worth. So each of these bars here is a 1-hour time window. What you can see here, the key metrics are number of page views, the number of visitors, and then the response time. So here, the busiest time of day starts from about 9 a.m. UK time, going through the UK working day. But actually, the page load time is better during the working day, even though there's more load. The page load time is better than it is here, say, for example, at 5 o'clock in the morning, where the page load time is a lot worse. And the reason for that is that the users that were active during that time of the day were those users out in Asia that are on higher latency connections. So you can look at trends over time here. All the data gets stored historically, so you can look back to any time range you like. You can look at before and after you've made changes to the system to see whether that change had any impact on performance. And we can actually record changes within the system as well. So the next thing to show you here is the view. So these are all the things that are being captured by WebTuner. And so you can have a look at performance by any of these different elements. So for example, a nice one to look at is performance by browser type. So I mentioned in my presentation that there is a correlation between the type of browser and performance. So newer browsers typically get better performance than older browsers. So you can see that here. Maybe if we just filter on Internet Explorer browsers and then sort by the page load time, it's pretty clear there. So IE6 has by far the worst performance. It takes 11 seconds on average to load the page, although thankfully not many users are still using IE6. And then if you look all the way through to IE11 is the fastest browser. That has a page load time on average of 1.63 seconds. So this kind of information can often give you a clear justification that upgrading people's browsers is one way of improving performance. One of the other drill downs that you might be interested in is to have a look at it by page, because as I said earlier, it might not be every page on the entire site that's running slow, but it might be specific pages. And this is a good way of kind of highlighting which pages have the slowest performance. So in this case here, this one at the top of the list has an average of 8.8 seconds. It also happens to be the one that's getting the most users and the most page views. So if you were prioritizing, this would be the page that you need to optimize first of all. And what you can see here is time to get the first byte of that page is relatively quick. It takes 0.9 seconds. So that's telling me that the server-side response time for that page is good. But then the time then to load the remaining part of the page, all the contents within the page, is very high, almost 8 seconds. So that's where most of our time is spent here. And you can see here from the number of elements on that page that on average it's got 63 elements, but it has actually, if you look at the max and the min there in the pop-up, the number of objects on that page can be huge. It can be over 1,000, which is obviously a lot. And so having that number of things on the page will obviously cause performance problems. So in that case there, the solution would be to have a look at the content, try and reduce the amount of content, strip down the page, and to make that page a lot smaller in terms of number of objects. And what you can see as well, looking at the URL, this is the default.axpx, so this is the home page for this particular customer. It's the one that most of the users are hitting each time they open their browser. It's that very first page. And so having a poor experience on that first page is then going to give that negative impression about SharePoint as a whole, because that's their first impression, is that first page there. So there's lots of things you can do, lots more reports, lots more ways of kind of drilling down into the data. You can click into these and then slice and dice the data in lots of different ways. But as a 10-minute overview, that's what I wanted to leave you with. If anybody wants to get hold of this, wants to try this on their own site, then we do offer a 30-day trial. Very simple to set up. As I said, you just need to drop the JavaScript in there, and we can create an account for you. So if that's of interest, then get in touch with us. Or if any of the other things that I talked about are of interest, any of the acceleration, any of the other monitoring tools, get in touch, and we'll be happy to help. So just finally, before we wrap up, has anybody got any questions around WebTuner? Let me just check the questions panel. I don't think we've had any new questions come in. No new questions come in. So I think I'll probably wrap up there and just thank everybody again for joining today. And Zoe, I'll hand back to you.
Thank you very much, Mick. Really interesting to actually have that insight into WebTuner, and there were some aspects there that really stood out for me on the effective performance on performance of browser type, and being able to get that sort of granular about individual pages and the problems that they might be causing. So very illuminating, thank you. And we appreciate everyone joining the presentation. Have a good day.